Welcome to the Explainer. So if you are a cloud certification exam taker, especially one gearing up for that Microsoft AI-300, you are absolutely in the right place today. We're bringing some serious high energy to tackle the Microsoft Certified Machine Learning Operations Engineer Associate Challenge. We're going to break down how to actually master MLOps and GenAIOps on Azure. Because, let's face it, just memorizing textbook definitions, that's simply not going to cut it anymore.
Okay, let's dive right into this by exposing a pretty hard truth. Why won't memorizing trivia help you pass these complex enterprise cloud exams? Well, the AI-300 is all about operationalizing machine learning, generative AI, and intelligent apps at a massive enterprise scale. The exam throws you into real-world architectures. If you only know what a service is, but you don't know how it inherently interacts with other services under super strict security and automation constraints, yeah, you're going to get stuck.
And honestly, that is exactly why we're looking at some fantastic materials from cloudcertificationstore.com today. They are absolutely the go-to destination for serious cloud cert materials. We're talking totally free guides and super affordable, scenario-based, exam-style practice questions. Notice I didn't say flashcards. These are deep dives designed to build real-world architectural expertise across AWS, Google Cloud, and for our focus today, Microsoft Azure. Just to put this into perspective, over 90% of these scenario-based questions closely reflect the actual difficulty and the exact decision patterns you'll face on the live test. You aren't just prepping for a passing score here, you're prepping for a real-life production environment.
All right, let's drop right into the hot seat with our first exam-style question straight from the source. We're focusing on automating MLOps infrastructure. Picture this. Your platform team needs to create Azure machine learning workspaces for dev, test, and prod. Each environment has to be provisioned consistently, reviewed through pull requests, and, here's the real kicker, deployed entirely without manual portal steps. So, how do you do it?
Well, you've got a few paths here. Do you manually create each workspace in the portal and just export the config? Do you let the data scientists build their own personal workspaces? Rely on Azure storage account templates? Or do you leverage infrastructure as code with Bicep and GitHub Actions?
So the crucial point to remember is that manual portal creation utterly fails enterprise standards. Exporting a configuration after you manually build it, that just massively increases the risk of dangerous configuration drift across your environments. And personal workspaces? No way. They completely bypass governance and network controls. That leaves leveraging infrastructure as code as the absolute hero's path here.
Here's why. Bicep supports repeatable infrastructure as code deployments for Azure resources. And GitHub Actions? That acts as your engine. It completely automates the deployment process and critically enforces review through pull requests before those changes are ever applied to your environments. This totally reduces manual drift and ensures your dev, test, and prod setups are just perfectly aligned.
Moving right along, let's tackle a scenario that trips up a ton of engineers: securing training data. Say your company stores training data in Azure Data Lake Storage Gen 2. Your Azure machine learning jobs have to access only approved folders, but the platform team explicitly wants to avoid storing any secrets in your pipeline definitions. How do you pull that off? You might initially think of using a storage account key, a shared access signature, or maybe a managed identity. Oh, and right off the bat, storing plain text credentials in GitHub, that is a massive security violation. Please don't do that. Shared access signatures, while technically scorable in some contexts, are still secrets that have to be meticulously managed and constantly renewed.
The absolute winner here is managed identity. See, storage account keys usually provide access that is just way too broad, making them incredibly hard to protect and rotate safely. Managed identity, on the other hand, operates directly through Microsoft Entra ID. It completely eliminates all that secret management overhead. It's a real game changer.
And this brilliantly illustrates how you can lock down your AI workloads without hard-coding a single password. It's really just 3 steps. First, you assign the managed identity. Second, you scope the role assignment specifically to the folder-level structure in your data lake. And third, you run your pipeline securely. It perfectly satisfies those strict enterprise security requirements.
Okay, let's pivot for a second to experiment tracking and model governance. Imagine you're training a classification model multiple times with different hyperparameters. Your team absolutely must track the metrics, parameters, and artifacts to compare these runs and pick the absolute best model candidate based on validation accuracy. What tool are you grabbing?
If you look at options like Microsoft Entra Conditional Access, Azure Storage Lifecycle Rules, MLflow Experiment Tracking, or Azure DNS Private Zones, well, you have to analytically separate the infrastructure tools from the actual data science frameworks. 3 of these deal with back-end infrastructure and have literally nothing to do with data science experiments.
What's really critical to grasp here is how MLFO acts as the definitive source of truth for comparing candidate models. Within Azure Machine Learning, MLFO is the industry-standard, fully integrated engine used for experiment tracking. It systematically records everything for you. We're talking your precision, your recall, F1 scores, and all your output artifacts.
It's super helpful to realize exactly why those distractors fail. Azure storage lifecycle rules, they simply move or delete blobs based on age or access tier. Microsoft Entra controls user sign-ins, and DNS zones resolve network names. None of them track machine learning metrics. If you want to actually compare runs based on tracked evidence rather than just human memory, MLflow is for sure your answer.
Let's zoom out a bit and see how this all fits into the broader MLOps cycle that you absolutely must master for the AI-300. It flows like this. You prepare your data, you train and track everything with MLflow, you register that model as a versioned asset for absolute traceability, and finally, you deploy it to a managed online endpoint for real-time inference. That right there is the end-to-end operational architecture you're being tested on.
But hold up, the AI-300 isn't just traditional machine learning anymore. How are you planning to handle the cutting-edge Gen AI Ops requirements of this certification? Microsoft has heavily integrated generative AI operations into this exam, specifically using Microsoft Foundry. You really need to know how to effectively deploy, evaluate, monitor, and optimize these intelligent applications.
Thankfully, the cloudcertificationstore.com practice questions thoroughly cover these advanced topics. You're going to be tested on some really critical skills. Things like using provisioned throughput to guarantee capacity during peak hours, leveraging strict role-based access control to separate your prompt developers from your network admins, versioning your prompts through JIT, and evaluating models based on relevance and groundedness metrics to literally stop hallucinations dead in their tracks.
There's a quote from cloudcertificationstore.com that hits the nail on the head. Every practice set is engineered to mirror production-level decision-making, not just exam trivia. And honestly, this philosophy is exactly why it's the premier destination for serious cloud professionals. When you practice real scenarios, like testing prompt quality with a CI/CD GitHub Actions workflow before it ever hits production, you aren't just memorizing, you're actively learning how to be a senior AI engineer. Prepare, practice, pass. That's the motto. By diving into these 500-plus scenario-based exam-style questions, you can finally ditch the flashcard memorization and start building real architectural expertise. You actually learn the why behind the what, complete with incredibly detailed rationales for every single architectural choice.
So I'll leave you with this final, somewhat provocative thought. Are your cloud skills truly production ready? Like, could you seamlessly automate an ML workspace or secure a generative AI endpoint today, right now? If you want to pass the AI-300 on your first attempt with absolute confidence, go visit cloudcertificationstore.com to test your readiness with their expert practice questions. Thanks so much for joining me on this explainer, and hey, happy studying!